Alex.
Okay. So again, so that's why I instruct you all the students. So you have to join the class before 5 or 5 minutes. Then it will be not a problem for you. Okay. Right. So now again, I will resume the class now. So classification of is RP techniques based on the what type of starting material. Sorry, it is spelling mistake. It was the starting material. So what is the input material you are going to use? So that is uh, like this based on that how you are going to like that these RP techniques are classified based on the starting material. So these based on that they are mainly classified what type of material, the form of material, whether the form is liquid form or solid base or powder base. What is the form of the material? Based on that, they are classified into liquid based RP, rapid prototyping processes, solid based rapid prototyping processes, and powder based rapid prototyping processes. Mainly these earlier mainly I discussed about the what type of manufacturing principle you are going to use. Based on that, they are classified into subtractive, additive, and virtual type of RP uh, manufacturing processes. And based on the what form of material, starting material you are going to use. Based on that, they are mainly divided into liquid based, solid based, and powder based. Liquid based, or solid based, and powder based. So in the liquid based rapid prototyping. So so what is starting material? Mostly we'll use the some different resins and we'll use the polymers. Mostly nowadays most of the to develop a prototype model are using the different polymers we are going to use to develop a prototype model. So based on that mainly there are different process are there among that important liquid based rapid prototyping process are stereolithography, solid ground curing, droplet deposition manufacturing. These three comes under the liquid based rapid prototyping processes to develop any prototype model by using the input material or form of material will be the in the liquid form. Then these are the very important process like stereolithography process, solid ground curing, droplet deposition, manufacturing. So according to our syllabus, we are having only, as per our syllabus, we are having only two different processes. One is stereolithography, another one is the fused deposition modeling. Among these two, this stereolithography process that comes under the liquid-based rapid prototyping process where we are using the liquid polymer for as the input material as per the syllabus. So these are the three important liquid-based rapid prototyping, and among these three, we're having, as per our syllabus, we're having the stereolithography process. And next one is the solid-based rapid prototyping, where we are using some small plastic sheets or plastics, rods, small rods, smaller diameter rods. We are going to smaller diameter plastic wires. We are going to use as the input material. Then those are known as the solid-based rapid prototyping material, where the form of the material is the solid. We are going to use some metal sheets, are going to use some solid continuous small solid polymer wires you can use and these among these solid based rapid prototyping there are two important solid based rapid prototyping process are the laminated object manufacturing. Another one is the fused deposition modeling, laminated object manufacturing, and fused deposition modeling. So, as per the syllabus, we are having the second one, that is the fused deposition model. What is the working principle, and what are the advantages and what are the applications? Those we'll discuss in this fused deposition modeling. Next one is the powder-based rapid prototyping, where the form of input material is the powder form. We will use the powder form of material. Then it comes under the powder-based rapid prototyping methods, where some important powder-based rapid prototyping process are selective laser sintering, three-dimensional printing, and laser engineered and net shaping. These are the different comes under this powder-based rapid prototyping processes. And already mentioned that whatever the process, whether it is a you are using what, like whether it is a stereolithography process or selective laser sintering or another any technique you are going to use in all these rapid prototyping process, they already mentioned that works on mainly three different steps, that is pre-processing, processing, and post-processing. So in the pre-processing, so we can observe the first step, step one, that is creating a 3D CAD modeling. So in this 3D, like by you can use any like CAD software package like and like or AutoCAD, or you can say SolidWorks or Unigraphics or Solid Edge, different CAD software packages you can use, and by using that can develop a 3D CAD model. That is the first step. So after that, we have to convert that into the STL format, stereolithography file format. You have to convert. So after that, then check the FTL means then in the STL file format. Once you are converted, means all these different nowadays the softwares that having this STL file format. So once if you're converting STL file format means it will convert the entire that 3D models. It will be a all the entire 3D model will be divided into different number of slices into different number of polygons. So that like that a 3D model will be converted into STL file. After that, we have to check the STL file and if any problems or any like errors are there, then you have to fix that STL file. And after that, slicing model into layers. After that, whatever the like desired thickness you want, 0.2 mm or 0.4 mm, like that, you have to specify the layer thickness. So you are slicing the model into layers. So you are specifying the what is the you are giving the input regarding the layers. And after that, the next step is the producing the physical part. So by whatever the machine you are using, stereolithography or selective laser sintering, additive manufacturing machine, that machine will, as per the STL file, it will produce the this prototype model. So that is the producing a physical model. So this 3D CAD modeling and this up to this slice model, like checking STL file and if it's necessary, and next one is slicing the model, specifying the layer thickness. These all steps are pre-processing steps. Before the processing of the product were performed, those are the pre-processing steps. So after that, you are transferring the file to the this particular rapid prototyping machine, where as per that file format, it will apply the layers layer by layer. It will apply the like resin or polymer, and once it is cured or once attached, the entire model is completed. Then that complete process is known as the processing. After the processing, we already mentioned that sometimes we need special supporting structures. We have to construct such a way that supportive structures will give support to the it will give support for the layers. For that, we are you may first before the creating the model, you have to create the supportive structure. So that supportive structure also you have to remove. So this removing of supportive structure and also some polishing operations are required and some painting operations are required. These are comes under the post processing. So 3D CAD model, slicing the file STL file, and giving slice thickness input. These are the pre-processing. Producing a physical model, processing, and after that removal of any supportive structures and polishing and printing operations. These are comes under the post-processing steps. So these are the things. Whatever step I mentioned, basic operating principles of RP, they are mainly building computer model. So that model we are going to build by using any CAD system or a CAD CAM system. You can model that one. After that, converting the model into STL file format. So STL file format is a stereolithography file. Then in a standard format. Then after that, STL file will approximate the surfaces. That will be STL file will be that as per the design 3D model. It will that model will be approximated into number of polygons. And after that, as per the STL file format, fabricating the model, building a model layer by layer will be applied and over the supportive structure, and you are going to develop a 3D model. Maybe you are going to use some liquids, or you can use some powders, or you can use some solid materials, and that may get cured, and after solidification you are going to have to remove the product. So for that, first you have to remove the supporting structures. After that, extra any material you use, that also you have to remove, and you have to cut the prototype from the supporting structures. And after that, post processing, where you have to performing all the this particular painting operations and polishing operations. These comes under the post processing. So once you manufacture the components, we'll cut the product, and after that, whatever the to make to give some aesthetic looks to the product, we need some polishing operation, and we need some painting we have to apply. So those comes under the post processing operations. So these are different rapid prototyping processes where I already mentioned that based on the what form of material you are going to use, whether it is liquid form or powder form or solid form. So these are the different processes. Like in the liquid form, you can observe that the process is stereolithography process. Liquid, the form of the material is liquid, and process is stereolithography, solid-based curing, fused deposition modeling, and ballistic particle manufacturing. These all processes comes under the liquid form rapid prototyping processes. And layer creation technique, here the liquid layer curing, the curing. So here and liquid layer curing and milling extrusion of melted plastic. In the case of solid waste curing and ballistic particle approach, droplet deposition. So the droplets, liquid droplets will be applied, and after that it gets solidified. So in the case of the ballistic particle approach, and so here how the phase change is going to occur, that is photopolymerization is going to happen in the case of liquid layer curing, and photopolymerization in case of solid basis curing, and solidification by cooling. So, and both in the case of FDM and ballistic particle and manufacturing, in the photopolymerization, so once it is solidified, then after that it will be placed in a separate liquid chemical to have the to get the proper solidified component. And materials like liquid, you can for a liquid type of rapid prototyping, you can use the photopolymers, and solid based curing you can use the photopolymers, and for fused deposition modeling you can use the thermoplastics and ABS and different types of polymers you can use. And also one of the option is for the ballistic particle manufacturing, the material polymers and wax you can use. And powder form, the process like three-dimensional printing and selective laser sintering, these processes where you use the powder form. And where layer creation technique is layer of powder will apply, and after that laser will get applied, and due to that laser the powder get hardened. And phase change, there will in the powder form there is no phase change. And in the case of selective laser sintering, laser driven sintering or melting going to occur. Mainly the powder sometimes it may even melt, and after that it will be solidified. And can use different materials like ceramics, polymers, metal powders, and different polymer metals. For a selective laser sintering, you can use the polymers with binders. To give the strength, we will add some binding materials. And another form of material is solid type of form of material you can use, where the process is the laminated object manufacturing. And there deposition of we will apply the sheet materials, and after that layer by layer will apply the sheets, and that will be get attached, and we can use as the papers and polymers we can use for the as the materials. So this is one of the important process, that is stereolithography process. In the stereolithography process, you can observe this diagram may consist on vat, that is a tank, and there we'll use liquid polymer. Okay, this is this diagram, the layout of the diagram. Layout of this stereolithography process, and there will be a platform. This one is the platform where we'll place first initially we'll apply some supportive structure, which is a supportive structure, and after that then we are going to on this the supportive structure we are going to like applying the this the entire model is going to prototype is going to fabricated. So here we are going to use UV laser light source going to apply over the particular first initially this platform. So this is the final product location on this platform. Initially this platform will be at the topmost at this particular location where initially when you are applying for example we assume that the 0. Some 4 mm thickness of layer we have to apply. So as per that you STL file format then 0.454 mm thickness of this platform will be lowered, and then by this as per the STL file format is laser will apply the UV laser will apply the light, and due to that this liquid wherever this UV light it will scan in XY direction as per the 3D model. So already we created a 3D model, and after that we created a STL file. So as per the STL file format, the UV light source. So this UV light source will operate in X and Y direction, and as I say, first we will lower the platform. So whatever thickness as per that will operate that means that a stereolithography mission will operate the platform, and then due to the UV light source, right, UV laser light source, then it will operate in XY direction. So like this it will operate in one particular layer, and due to that UV light source, the liquid polymer will be solidified and it will become a solid layer. Once at like 0.4 mm thickness of a particular solid is get solidified, then after that immediately then the platform will lower. Next step again, another liquid polymer for will operate for the next layer. Again, when immediately the UV light source again it will operate in XY direction, and like that it will again cure that liquid polymer. Due to that UV laser light source, then liquid polymer will be solidified and form the solid form. So like that some n number of layer once first it will lower the platform, and the liquid polymer will be applied, and the UV light source it will scan this particular whatever the shape we specified in the STL file. So as per that STL file format, as per the shape, there is the UV light source. It will scan the different that particular. It will move in different direction, x moment and y direction. Whenever it is scanning the particular liquid layer on a particular location, due to that UV light source, that particular liquid polymer will get hardened and it will be solidified. Like that, we are going to for that developing a product. Again, for the next layer, whatever the desired thickness, the platform will get lowered and liquid polymer will be applied, and immediately the UV laser will scan that particular whatever as per the STL file format, it will scan as per the shape, and it will whenever it is scanning immediately due to the UV light source, it will the liquid polymer will be solidified and it will form a layer. Like that layer by layer it will scan the liquid polymer, it will develop the final product. Once you develop the the final product is created, so mainly what are the mainly I mentioned this what are the processing steps mainly works on the this stereolithography process mainly works based on the principle of curing the liquid photon, that's liquid polymer we are going to curing. So before first you have to lower the platform and applying the liquid polymer. So once you are applying this laser beam, that UV beam is scanning that particular liquid polymer. Due to that, it is getting cured, and that is good. After that, due to that UV beam light, it is getting cured, and the solid layer is going to form. So that is the working principle of this stereolithography process. Mainly each layer, the range of thickness of that particular layer maybe ranges from 0.076 mm to 0.50 mm thickness, and even thinner layers also can provide for better resolution. And like the scanning speeds of this UV light is ranging from 500 to 2500 mm per second. So already mentioned that once you apply that liquid polymer, then immediately the UV laser light will be like that scans in X and Y direction over that liquid polymer. Due to that, that liquid polymer is getting cured and it is getting solidified. That scanning speeds are ranging from 500 to 2500 mm per second, and accuracy, whatever that final accuracy of the product, maybe you can maintaining uh, in the range of 0.012 maximum of 0.2 mm range you are having the accuracy. This is the next process is the fused deposition modeling. So in stereolithography process, the input material is the liquid form. So in the liquid form of material, each time that you are lowering the platform, which is the platform, you are lowering the platform, and after that UV light source is scanning the liquid polymer in X and Y direction as per the specified in the specified path as per the STL file format. Whenever it is scanning that UV light, UV light, the laser light is scanning the particular liquid polymer, the liquid polymer is getting cured and will be solidified. And in fused deposition modeling, where we are using the solid material, thermoplastic material, or some different polymers you can use for as the input material in the solid form. They are some bunch of liquid, like a thermoplastic filament reel. We are going to use the input material. So this input material we are giving to the fused deposition modeling machine. So then during this operation, fused deposition modeling operation, this there will temperatures will be generated in this particular heated FDM head. Due to that temperatures, that thermoplastic or wax filament gets melted, and these at the same time that this heated FDM will move in X and Y directions, as per the STL file format. So the input material you are given, for example, you see this you know that injection molding process. In the injection molding process, where we are applying, we are using different polymer, these pellets into the hose, and whenever you increase the temperature of that injection molding machine, due to the heating coil, it will melt that pellets. So like that, here also supplying the filament polymer to the FDM head. So the FDM head, to the temperatures, it will melt that particular polymer material, and at the same time the head, FDM head, will move in X and Y direction. Here this FDM head will move in this particular X direction and Y direction as per the STL file format, and will apply a layer. Once it applied one single layer, immediately it will lower the platform in Z direction. So Z direction, to give some thickness to that layer, to increase thickness of the layer. You apply one layer, immediately after the application of the layer, as per the instruction by the machine, the table platform will be lowered in Z direction, and immediately again this particular head will move in the X and Y direction to apply. So like that, it will apply the. So if you see our CNC machine, milling machine, how it is going to operate, will X direction and Y direction. Like that, the head will move in X and Y direction. At the same time, it will apply this thermoplastic liquid it will, because as per the temperatures, it is melting that thermoplastic that will be a place, or this is the platform. So you can see this is the platform, the diagram. Here will apply use some supporting structures, pictures you can use for foundation, and this is the supporting structure, and this is the complete plastic model what we that in this diagram is going to observe. So to create that model, after creating one layer, again as per that direct STL file format, the head will operate and it will inject this particular liquid. Due to the heating, it will melt that thermoplastic filament, or if you are using the wax, it will inject the wax over the in that particular platform. It will inject, and one layer will be applied. Once one layer is applied as per the STL file format, immediately the machine will lower the table in the Z direction, in the downward direction, for the for applying the next layer. That is the working principle of this fused deposition modeling. A fused deposition modeling where a robot controlled extruder head will move in X and Y directions. So, and also at the same time, once it is moved in X and Y direction and applied one layer, then immediately the table will move in the Z direction in the downward direction, and the next layer will be applied by this whenever this extruder is moving in the X and Y direction as per the XTL file format. So like that, different number of layers are going to apply over the platform. So mainly you can use the materials polycarbonate, and you can use ABS type of polymer, and also based on the requirements, even you can even use the metals. So it can, whatever the fused deposition modeling, this even can be suggestible for the metals also. But with those temperatures that are generated by using this fused deposition modeling, that even melt the some type of metals, not too like melting temperatures, like low melting point metals. So we can use this fused deposition modeling, and a layer thickness that is applied by using this fused deposition modeling is 0.05 mm, and accuracy of this fused deposition modeling is 0.1227 to 0.254. When compared to the stereolithography process, the accuracy of this fused deposition modeling is very less. Accuracy is very less. So the applications of rapid prototypes, they already mentioned in other classes also. They are going to use in different mainly to get verified by the product these developers, product designers. For verification of the design model, we are going to use this rapid prototyping, and also to check the whether whatever the concept you develop, whether it is going in the right manner, or whether in the wrong direction it is going. For that, to checking the proof also, you can to check the concept, you can use these rapid prototype methods, and also whether whatever the model you created design model, whether you that by fabricating prototype model, you can say that whether whatever the as per the design specifications, you as per the dimensions or shape, whether the appropriate shape you as per the design is specified, whether such to check that whether any by seeing visually they can come these design engineers, they know that they can have the proper the entire idea once they see that particular shape and size, and also how the particular different sub elements are fitting into the different elements, and those fit and dimensions also can be for those verification we are going to use this rapid prototyping methods we are going to use to fabricate, and also to design verification also we are going to use this rapid prototyping, and sometimes different testing simulation models like those also for simulation, to after the simulation to perform the different checks, testings for testing, to perform different tests like some stress analysis type of simulations, or some deformation tests we can perform. So for that also can use these rapid prototypes. And also other than that design verifications, and you can use to even this rapid prototyping for to develop the tooling and patterns, especially for to develop some molds for the investment casting. Investment casting patterns will be prepared by using this rapid prototyping, and also sometimes different bricks and pictures can be fabricated by using these rapid prototypes. And most of the nowadays healthcare industries, they are using these rapid prototypes because there are different materials dental applications, hearing aids, all these things are manufactured by using this rapid prototyping methods. Nowadays, most of these healthcare industries, because whatever the if you are doing any surgery for the knee, so whatever the component you are inserting that particular in the human body, it should be compatible. It should not create any reaction. So that such type of fabricating biocompatible materials or biocompatible here, aids, hearing aids, or maybe some other applications. We can use these rapid prototyping applications. And advantages already mentioned that is when compared this rapid prototyping, especially these this additive manufacturing processes are very fast and accurate. So by using these additive manufacturing processes, within minutes or within hours, you can manufacture a desired some product. Even some 2 or 3 days, within days we can manufacture a big assembled product also by using this additive manufacturing. So these processes are very fast and accurate, and these so most probably why I'm mentioning especially additive manufacturing, because they are you can manufacture, can use different other techniques also, like subtractive or virtual manufacturing. But most of the companies nowadays they are using additive manufacturing. That's why these process additive manufacturing process manufactured components are having the superior quality, high good surface finish they are having. And also separate material can be used for component and support. So already mentioned what you've seen observed in the is the fused deposition modeling and selective laser sintering, where so we'll, other than to avoid the wastage of material, for supporting structures we will use separate material, and parent material will be different. That is the one advantage of this process. And this process don't require any jigs and fixtures. We are because we are even supporting structures also, we are going to create by using these additive processes. And also there is no need of molds and other tools like casting or the material removal process. We need some special tools, but here in the process we are going to applying the layer by layer, maybe in the form of powder or maybe the liquids we are going to use. For that we don't require any special tools and molds. And also post processing include only finishing and cleaning. So in if you take some machining operations, there will be some different number of operations you have to perform, like milling operation. After that, I have to perform some again finishing grinding operation. Okay, and after that, the holes required, I have to finish. I have to use that like this uh, drilling operation, like that I have to perform. But in the case we are using these additive manufacturing for the rapid prototyping, then such a type of much increased finishing operations are not required. That what those we are observing in the conventional process. those things are not required. That much post-processing operations are not required in the case of rapid prototyping. And also most probably for developing prototype, that we are going to use the polymer materials. And also these when compared to these metal removal processes, these additive rapid prototyping technique, where there is somewhat no on minimum material wastage, because you are not removing the material, so you are adding the material layer by layer. Even the with the you are developing the model with the holes and with contours, where not even you are applying any drilling technique. That end product we are going to get in all the slots and holes will be developed by only using the layer by layer technique. So there you are not removing any material. So there is a minimum material of wastage. Maybe that minimum also mainly in the case of during especially supportive structures or some finishing operations. There will be a minimum material wastage. And also due to this rapid prototyping, the lead already mentioned that the lead time is getting reduced due to the rapid prototyping, because once your concept model is manufactured within a shorter period of time, and after that you are performing various tests over that, and that you are completing in a shorter span of time. So due to that, your lead time is get reduced, and that due to that your production rate may get increased. And limitations, the many like cost of operating is the costlier one. And also sometimes this in especially in fused deposition modeling, if you are applying layer by layer, there are some different layers, we can find out that some uh, gaps, or we can say some layers. The in final product we can observe some marks, layer marks over the product. That is somewhat disadvantage. If you are using is that, especially you can find out in the fused deposition modeling. But in stereolithography process, where such a type of defects we can't observe. And sometimes if you are not maintaining appropriate temperatures, or that curing temperatures, all those things, due to that the final product gets distorted. I mean the shape get the final shape may be violated, and you won't get exact shape if you are not maintaining proper operating, whatever the parameters are not maintaining properly, then the shape may be get distorted. And also these RP techniques are only suited for most probably some wax and polymers, different types of polymers, and certain low melting temperature materials only. It is not usable for all the materials. And this cost of these machines are very high. So these are some limitations of this rapid prototyping techniques. But in spite of all, only the because most of the cases we are using this rapid prototyping only for the developing prototype models, and so there can't only the most probably are using the polymer material for developing the prototype. So that's not a big problem with the limited range of materials. And that requires them, because it is we are now only developing the prototype model, so that will be not a big problem. And again, you are going for the mass production, we will use separate machines you can use, where you can use that required actual materials you can use to develop a particular product. So that these are all the disadvantages. So that is the end of the unit 1. Till now I discussed all the non-traditional methods and rapid prototyping. Almost I taken, I think, 14 classes, I think, except first 2 classes. That was 2 periods only for introduction part, and after that I taken nearly 12 classes for to complete this unit 1. Mainly I discussed about what is the use of non-traditional machining methods, and mainly these non-traditional methods are used by because whatever the like difficult to machine or high strength materials to machine the high strength materials and to machine the intricate shapes. Difficult to machine materials are machined by using these advanced or modern manufacturing methods. After that, I discuss about different classification of related to the this non-conventional machining process, and uh, and also how these non-traditional machining and rapid prototyping are connected to the precision and lean manufacturing. So by using this rapid prototyping, there is a we are avoiding like wastage of material. So we are reducing the wastage of material. So that's why it comes under the lean manufacturing, and also the precision levels of these machining methods of advanced machining methods and rapid prototyping accuracies are very good. So that's why these two processes are well connected to the ultra precision and precision manufacturing, and also they are connected because the material removal rate is somewhat less in the case of modern manufacturing methods. Due to that, there is a less wastage when compared to the conventional methods. So after that, I discuss about what is rapid prototyping. Mainly, is rapid prototype. Is prototype nothing but a scaled model that maybe we are developing maybe two dimensions or to the reduced dimensions that we are going to develop to check the whether the product is giving its performance in the appropriate manner or not, and to check its like shape and dimensions, all those things. There is a requirement to develop a prototype. For that, there are different prototyping techniques are there. Today, I discuss about different forms of rapid prototyping techniques. So based on the what is the input material you are going to use, whether you are using the liquid material or whether you are using the solid material or whether you are using powder form of material. So based on that, they are classified into liquid type, solid type, and powder type of RP techniques. And after that, I discuss about the fused deposition modeling, and another one is the stereolithography process. In stereolithography process, uh, mainly where there will be a vat or one tank. There we are having the in the machine. In there we are having one platform. So you have to lower the platform as per the desired thickness. Then as per that, once you lower that platform, immediately uh, the stereolithography machine, it will apply liquid resin. Then after that, once it apply the liquid resin, the ultraviolet laser light will be scan the liquid laser only in appropriate direction that is specified by STL file format. Due to that, that particular liquid resin will cure and it will be solidified. Okay. After that, immediately to apply the next layer, the platform will lowered again in a downward direction, and next immediately next layer of liquid polymer will apply. Again, the ultraviolet laser will scan that particular liquid polymer in appropriate direction as per the specified by the STL file format. That is in the case of the stereolithography process. And in the case of fused deposition modeling, in the fused deposition modeling, the fused deposition modeling machine it consists of fused deposition head. There you are giving some input material that polymer filament we are giving as input material, and we are supplying continuously this polymer material to the particular is our input material to the FDM head. Then FDM head will get heated. Due to that heating, the filament will get melted and it will apply one layer of over the platform. And immediately after applying the one layer, then the platform will get it will be lowered in the downward direction, and next it will apply the next layer like that. Uh, we are applying the different number of layers. Disadvantages, sir. So these are the different topics that what I discussed in the unit one. So I completed the entire unit one. So I just downloaded two different videos related to the particular fused deposition modeling and lithography. You can even check in those things in your YouTube also. Yes, I will operate. I'll those two videos, and after that I'll complete. I will end the class today. You won't get I think audio. You will get the video. That is enough for this understanding the concept. Okay, I think you are getting the lessons. So in this, already mentioned that as per the 3D model, first we'll create the 3D model. After that, we'll convert that into STL file. That file will transfer to the machine. So in this process, first it is applying one layer of the liquid polymer. That. So after the ultraviolet laser, it will scan the resin. This is a liquid polymer. Here it is scanning as per the STL file format. So whatever the file format is given as per the direction, you will trace all the particular liquid resin, and due to that it will get solidified. The next layer will apply liquid polymer, and again it will scan the particular liquid resin. So like that it will once it is cured the first layer, the platform will get lower, and once you produce that component, you have to remove it from the supportive structure.
Screen not
And they
visible,
will liquid polymer, they will take it out.
screen is not visible, sir.
Okay, anyway, I think for not visualizing the screen, I will send this. I will upload these videos in our Google Classroom. We'll go through that. Okay, that is maybe there is a problem in the screen sharing. That's why somewhat problem. Okay, students, I will share these particular videos also. Okay, now just answer the attendance, and after that we'll end this today's class.